This is Brittany Epley, and she works most of her time here at in the lab here in this department. So she's pretty much an expert on microbiology, and so what she's going to talk to y'all about is what microbiology does in the lab and how that relates to people out on the street, you know, the general public. How does what we do in here relate to those people? So, Brittany, why don't you tell them what you know?
Well, a little bit about our day-to-day. So I would come in and I'll do our 24-hour cultures that were set up the day prior, and I'll read these. So we'll do anything from urines to throat cultures to wound cultures to sputums, anything body fluids, spinal fluids, anything that you can think of, any kind of specimen. And so our day-to-day is I'll come in first thing in the morning and I'll look at the 24-hour cultures, like I said, and these would be the cultures set up the day prior, the day before, and we'll read urine cultures, sputum cultures, body fluids, spinal fluids, wound cultures, any kind of bodily specimen you can think of. Pretty much we'll culture it for bacteria. So that's mainly what we do here is a microbiology laboratory, and we're looking for bacteria. Sometimes we'll isolate a few mycology organisms like yeast or mold, but it's mainly bacteria is what we actually ID and do sensitivities for. So whenever we work these plates up, we will sub them to the medias that will grow the bacteria, and then it will be put into this incubator. And this is a CO2 incubator at 35 degrees Celsius, and it is kept at a constant humidity, so that is optimal for the bacteria to grow in. So this is where we'll keep all that. Now it incubates to grow, and then when we read it, we'll see, for example, on a urine, you will see this is a prime example of E. coli. So this would be very common in a urinary tract infection, is what this would cause. Or if you have food poisoning, it can cause food poisoning. There's many different things it can cause. The most common, it's normal flora in the digestive tract, but it can become a pathogenic organism. So, can you just zoom in on that? There's your plate, and we have all kinds of different color indicators. So this is a biplate. We have the blood and we have the McConkey. So it's fermenting, it's pink because it's fermenting lactose, the sugars. That's why it turns pink. So we have that, and then here's another example. This is a strep, beta hemolytic strep. So if you have strep throat, so this would be what is growing in your throat, making you have all that pain when you have strep throat. So we isolate that here, and we're able to tell the doctor if that's what you have and that's what's causing your pain or not. So after we isolate it, we can ID it. We have many different bench tests that we use that we can get a quick ID. There's anything from the staph latex, coagulase, your oxidase, or your indole. And we'll use those for a quick ID so we can get the ID of whatever's causing the problem to the doctor as quickly as possible. Now, after we do that, we will set up an ID and sensitivity to confirm what we've done. And that is where we come over here. And this is called our microscan. So this is where we do the sensitivity. So this tells you what kind of antibiotics are going to be effective on the particular strain of bacteria that the person is infected with. So that way the doctor can know if he puts you on this antibiotic, how much he needs to give you, and what particular type is best for you to take. That way you can get better. So we set these up every day. Let me see if I can find an example one. I'll show you what one of these is. So here would be one of our negative urine codes. So I was talking about the E. coli. So this would be what I would set this up and see how it has all the different dilutions and all of the different antibiotics. And And so that's what we would set up. It would incubate in here for 24 hours, and then we would come back the next day and read what MIC, which is minimal inhibitory concentrations.
I see that you're really covered up, so what kind of safety precautions do you take?
So the basic laboratory safety precautions that we take here is your lab jacket and your lab gloves. You always have to have closed-toed shoes, hair up. Those are the basic standards. Now for certain things we do have goggles whenever we do. So on this guy, this is a biochemical reaction for the ID is what we use. So whenever I'm working with this guy and I have it open, it has lots of chemicals that you use for the biochemical ID. So I would wear these goggles while I'm messing with the chemicals or anything like that.
I see all your samples and stuff, and how much stuff, how long do you spend in this lab? Like every day?
Every day is 8 hours every day.
So every single day? We don't take it.
There's no day off. 365, 7 days. And now there is this, I read plates on here for day shift. Now, cultures come in to our BioGood and 24/7, every day, constantly. So whenever whoever's here will come see this, and we can show you. So this is our biosafety cabinet. So this is where, when specimens come in, they'll be set under here, ready to be set up on those plates that I was showing you. So this is, for example, here's a sputum, and here's a wound culture. So whenever I get something like that, then I'll grab the plates that are appropriate for it, and I will swab and streak for isolation. And we use a 4-zone isolation streak. So that's what this is. You guys have codes, right? And tag and all that. This is a level 3. Yeah. So there's that, and then also we have our blood culture instrument, which the computer's just over there, but the actual instrument is up in the sectioning. And those are monitored 24/7, constantly, every day. And those are just, what is that, like blood cultures. They draw a large amount, 5 to 10 mLs of blood. We put it in a culture bottle that has mediums in it to grow bacteria if it is in there, and they are rocked continuously and kept in an incubator at 35 degrees. And that will alarm anytime the instrument senses any kind of growth, and it'll alarm at any time and let us know, and we'll set it up. So that would be if someone was septic. That would be how we would be able to let the doctors know. Yeah, infection of blood cultures. So you would be able to let the doctors know what was causing, what bacteria was in the blood causing them to be septic.
So there's always someone here, like in here.
Always.
There's never nobody in.
Always. There's always at least 2 people. Yeah. 3 in the morning, you come in here, there will be somebody who will be working.